Assalamualikum OyaRahmatullahe OyaBarakatuhu. Welcome to my virtual classroom, MKA Classroom. Now let's start today's video tutorial. We will try to discuss a special topic, modified internal rate of return, or MIRR. This term is actually too much popular. MIRR, modified internal rate of return. A major weakness of the IRR compared to the NPV method is the reinvestment rate assumption. IRR assumes that the cash flows from the project are reinvested at the IRR, while the NPV assumes that they are invested at the firm's cost of capital. This optimistic assumption in the IRR method leads to some projects being accepted when they should not be. An alternative technique is the modified internal rate of return. Here, each operating cash flow is reinvested at the firm's cost of capital. So here we will see all cash flows are reinvested. The compounded values are summed up to get the project's terminal value. That means all compounded values should be summed up. The MIRR is the interest rate that equates the project cost to the terminal value at the end of the project. Basically, we use MIRR for non-conventional cash flows. Non-conventional cash flows. Non-conventional cash flows. Cash flows. Conventional cash flows where we use IRR, but whenever comes our non-conventional cash flows, then actually we cannot use our IRR. So there has a drawbacks. IRR has the drawbacks. Internal rate of return has a drawbacks for non-conventional cash flows. Non-conventional cash flows, what is the type? That is the negative plus negative plus. That's the formation of non-conventional cash flows. That means that is the total in a one project's cash flows. First is cash outflow negative, then inflow positive, inflow positive, again outflow negative, inflow positive, inflow positive. But whenever we our conventional cash flows, first is negative, then all cash flows are positive. All cash flows are positive. That means why here for the conventional cash flows we will see first one is cash outflow. That means our initial investment, then cash inflow, cash inflow, cash inflow, cash inflow, cash inflow. That is the conventional cash flows. This is the conventional cash flows. But then we use IRR. For this cases we use IRR, internal rate of return. But sometimes there arise different types of cash flows. That is, first is initial investment, that is cash outflow, then cash inflow, again cash outflow or initial investment. That means you can invest again, then again cash flow, cash inflow, cash inflow. That is a non-conventional cash flow. Non-conventional cash flow, that is the non-conventional cash flows. That's why these non-conventional cash flows, for we need the modified IRR. That means we have to modify that our internal rate of return. That's we have learned in our previous sections, the internal rate of return. That should be modified in this session. So here has the calculating procedures of MIRR, modified internal rate of return. At the cash flows are non-conventional, then we need MIRR. Steps of MIRR, modified internal rate of return. Convert all cash outflow to the present value. All cash outflow, that means all the negative cash flows should be treated as present value. We have to convert that negative cash flows to the present value. Convert all inflows to the future value. That means all cash inflows should be converted to future value. Can you see clearly? Yes, that should be. Yes. So convert all cash outflows to the present value. Convert all inflows to the future value. And step 3 equates step 1 to step 2. PV of step 2. That means this step should be again treated as present value. Present value of all cash outflow equals present value of all future value of cash inflows. So that is our formula. It is a very simple. Present value of cash outflows, that is the present value, and second step we convert all cash inflow to the future value, and third step this future value should be converted in present value. And whenever these two values are should be equal sign, then we can find our MIRR. Here is the formula. MIRR formula: PV of all outflow equal to PV of all AV of inflows divided by 1 plus R power n. Note, you may ignore all negative signs at the time of calculation. So you have this note can be remind you have to ignore all the negative signs at the time of calculations. Here as an examples that we can calculate it. Year and cash flows 0, that means it is our initial investment, and that is 800. Year 1 5,000, year 2 negative 5,000, that is again cash outflows. Then we then calculate MIRR. Our required rate of return is 10%. Now calculate solution. Step 1, calculate present value of all cash outflows. So that is the cash outflow 800, and that is the year 0, that should be turned into 0. Then you can write down the timeline 0, 1, 2. You can write down timeline for your better calculations. So here 0, 800, 5000 and negative 5000. So we have to calculate all negative signs to the present value. So here as 0, that means 1 plus 0.10 power 0, and this is the value 1 and 2. Negative 5000 has the power 2, 1 plus 0.10 power 2. In this way our value is 4932.23 by the calculating our calculator. Now step 2, you have to calculate all inflows to the future value. So here is only one inflows, then what would be its n's value? So in the time of future value, our line should be in right side. So here 5000 should be value of n1, that is the 5000 into 1 plus r power n, that is 1 plus 0.10 power 1, that is 5500 taka. And now step 3, we are using the formula of PV of all cash outflows, that is 4932.23 equal to present value of all future value of inflows. That is we have calculated 5500, that is our value, 1 plus IRR, 1 plus IRR power n. So n should be 2. Then if we cross multiply, then we found 4932.23, 1 plus MIRR power 2 equal to 5500, then 1 plus MIRR power 2 equal to, then 5500 divided by 4932.23, there has the value, then 1 plus IRR, here is the power, that's why it should be power half 1 by 2. There this has the value, so MIRR equal to 1 plus 1.0.559 minus 1, MIRR equal to 5.598%. So in this way we can easily calculate MIRR. We have another way to calculate MIRR. So there is another formula or another way how we can calculate MIRR. Using the required rate of return as the compounding rate, find the terminal value, that means future value of all net cash inflows, positive net cash flows at the end of project life. Yes, that we have already calculated. Using the required rate of return as the discounting rate, find present value at t equal to 0 of all net cash outflows, negative cash flows. So compute IRR. So same rules. In this way also the same rules. MIRR equal to terminal value inflows divided by present value of outflows power 1 by n minus 1. So that is the same formula, where n equal to projects live, n is equal to projects live. Now we will see compute the modified IRR given a required rate of return is 12%. Here as our cash flows 0, 12,000, 20,000, that is our cash outflow, 6,000, 7,000, 8,000, 5,000 and 4,000. All are cash inflows. That's why we have to calculate the future value of these cash inflows. then terminal value equal to, that is the 6000 carries. So you can write down the timeline to find out the value of n. 1 2 3 4 and 5. Here are 6000, 7000, 8000, 5000 and 4000. So what should be the value for 6000? 1 2 3 4, that is the 4. 7 1 2 3 3. So in this way you can easily calculate the value. So here is the total terminal value or total future value, and obviously this is the end. This is the ER0, that means this is the present value. So then if we use our formula, then it is easily calculate the MIRR. TV, that means this value. PV means this value 1 by n. N means 5 minus 1. Then that is our 14.24% is our MIRR. So MIRR examples with positive and negative cash flows. Already we have done it. This is our two projects. S has the two negative cash flows, and project L has also the two negative cash flows. So we know this very well. We have already done this type of problems. Okay, this all about today. Stay home, stay safe. Assalamualaikum warahmatullahi wabarakatuhu.